on, man. Let's do these ones. Okay. Right, ready that? Hello? Where are you? Where are you, man? Hmm. Here you go. Come on. Hmm. Hello? Can you hear me? Hey,
Hi.
how's everything? Sorry about that. Like, I think the Zoom link wasn't sent early. Okay. How are you doing today?
Good.
Okay. Let's just start off with actually, like, how was your math class? Did you guys had any new things to talk about? Like, or what are you guys doing in class? Like, what did you guys do this class this week? Yes. Do this.
All I did was order of operations.
Okay. Just like similar to what you guys did the other week?
Yeah.
Okay. Supposedly they want you guys to be doing exponents and like equations soon. So I guess maybe we can like just go off with what we did because you already know how to do that one, right? The PEMDAS.
Yeah.
Okay. So we'll kind of review what we did the other week, and then like move on to maybe like solving equations and inequalities. I'll introduce how you do those, but eventually, like maybe like next month you'll do those anyways, and then we'll just continue doing them. Okay. Were you able to get like some of the worksheets?
Yeah.
Okay, that's good. Did you practice them this week?
Yeah.
All right, perfect. Okay. So I guess let's start off with what we talked about last week. Do you remember doing this? Let's try doing these two. So let's start off with this guy, if you remember the exponent rules. Exponent rules.
Can we go over the rules again?
You want to go over the rules again? Okay. Let me go back to this. I think it's in here. Yep. All right. So do you remember talking about this first one right here, the product rule? So if you remember the product rule, when you have like two things, I'll just write right here if you can see it. If you have like two things that have the same base, and then your small number right here, and then you have like this being multiplied by the same base and another small number, what do you do with the small numbers over here?
Add them.
Yep, so that's the product rule, right?
Mm-hmm.
So 2 plus 3. I usually would write it like this. Like if you want to remember the steps, it's easier to like lay them out like that, and then eventually it's just going to be natural. So that's the one. And what about the quotient rule? This one is very similar to adding them, right? But in the quotient rule, what do you do?
Subtract.
Okay, and then like you kind of saw this last time when we did the examples. Is the trick to it is you just minus it from the small guy from the big guy, right?
Yeah.
So you just go like this, and then you go 3 minus 2, and so it's like 1/3. So quotient rule, product rule, these are pretty common. Yeah, these are the ones that you'll probably remember most. And then there's this one. There's the power rule. So the power rule is a little confusing because it's kind of like the product rule, but the difference is you have these parentheses. So if you take a look at this guy, so you have a parentheses, right? And then you have 3 squared. And then what if we had like 4 right here, right? So this one, you just times it by this guy. You don't add it because it's a parentheses. So it's like 3, 2 times 4, right?
Yeah.
So yeah, like this one, as long as you remember, like I always remember it's like if there's a parentheses, the same way if there's a parentheses with something, you just times it. So if there isn't any parentheses, it's like this a multiplication sign. Just go ahead and like add it. So as long as there's no parentheses, you add it. But if you have a parentheses, you multiply it. And another thing with this guy is so if you had like for example, this is kind of like an extension, of the power of a product rule. So this guy, what do you do when you have, for example, like 3, right? And then you had a variable here. We're gonna cover this a little bit with like once we solve the equation. So you have this 3x, and then you have maybe for example you had 3 right here, right? So 3. What do you do with this 3?
Add the exponent to both of them.
Yeah. Yep. So you add it to both of them. So 3, and then you have this 3, right? And then you just like lay it out like that. So you do that and then simplify. What is 3 squared? I think that's 27. And then like so x cubed, I can't simplify that anymore. So that's the one. So this, if you get this one, the power of the product rule, this is like the main like thing really, and then the quotient rule, I think you're good. And then the more we combine those, which we will in a little bit again. And as long as you remember like PEMDAS, I think you should be good to go, because you will apply PEMDAS no matter what. So this one, what about this one? Let's try to look at this guy. So 3 squared, and then you had maybe, oh no, I guess we'll do x right here, and then 3 right here. What do you do here?
Subtract.
Nothing is really the same term. So like this is already inside is already simplified, or I guess this guy, this is a 9, so you could go like that, and then you had 3, right?
Yeah.
And then this guy isn't the same as this guy. If they're not the same, if they're the same, like for example this one, if it's the same base, that's the only time that you subtract, like if it's the same base. But if it's not the same base, like this one right here, you had like a 9 and an x, you just leave this alone and then you work with this guy. What do you do with this 3?
Add it to both of them.
Yeah, so this guy, right? And then this guy?
Yeah.
Yeah, so it's 9 cube and then x cube. And whatever 9 cube is, that's like a big number. 729. 729 and then x cube. Okay. Let's try another one for that one. So what if you had like 2x, and then you had like 3 squared, and then you had this as squared? What do you do with that one?
add the squared to the 2 and the x.
And then what about this one?
And then add on to there.
Okay. And then like, let's see what happens when you do that, right? So you do this, because you might have to, like after you do this, you're gonna see something, you might have to simplify. Let me see if you do. Probably not this one. You don't have to simplify this. So, and you add it to this guy too, right?
Yeah.
So it's 2 squared x squared 3. 2 times 2 is 4. Let's see, what's 3 to the 4? That's 81. So 81, and then this is 4 x squared. Sometimes when you look at these guys right here, you may be able to like reduce this some more, but it doesn't look like you do. So I think you're good. So I think this is the most simplified form. All right, this is the fun one. So what is anything raised to a power of 0?
1.
1. So anything, right?
Yeah.
Even 0. 0 to 0 is what?
1.
1. So anything. This is like one of those greatest things, because then we've seen it and we're going to see it again, that you can remove one of the variables. You don't even need to solve for it later on. So that's a fun one. What about this guy? Let's look at this one. Negative exponents. Negative exponents is it's technically just doing the quotient rule. You know, the quotient rule is if every time you have this, but like when they say simplify, when your teacher says simplify, like you really don't want negative exponents. So like for example, you have 2 negative 2 and then like 3 negative 2, something like that, right? Like what do you do with the exponent?
You just subtract them from each other.
So okay, I guess I'll explain that better. You can't really subtract these from each other because the base right here is not the same. So like this is 2, right? This is 2, right? And then this is 3, right?
Yeah.
If they were the same, like 2 negative 2 and then 2 negative 2 like that, well, this is 1. Now you can subtract them from each other. You can do something with exponents because they have the same base. Okay. If they don't have the same base, the same big number, what do you do with exponents now?
Just
And
keep.
then, yeah, what is it? What do you do with exponents?
Simplify.
Okay. If you have like a negative exponent, you have to put them on the other side, right?
Oh, yeah.
Okay. So if you have like 2 negative exponents, I would probably do them one by one. So let's start off with this one first. So it's 2 negative 2 to the negative 2. I would probably put that at the bottom. So I'll keep this 3 first. It's negative 2. And then you times it by 2 to the squared, right? We move this guy, right?
Yeah.
To the bottom. Okay, but we still have this negative guy, right?
So then you move it to the top.
Yeah. So every time you have a negative exponent, you move it to the other side, top or bottom, and you make it positive. So now it's to the top and it's positive, and then to the bottom it's positive. And then obviously try to simplify. So what is 3 squared? That's 9. 2 squared, that's 4. That one is a little like weird, right? Like, but then you just have to remember that one.
Yeah.
Like, it's just one of those like, okay, once you know the basics of these, you have to like just look at a problem. Once like there's like so many things going on, you just have to look at a problem and apply each one of these guys. Let's try this again. Let's try 3. And what if you had this guy right here? What if this is negative 1? And you're applying it to our parentheses now. And then let's see, 3 squared. Let's look at this. What do you do first?
First, you put the exponent on both of them.
Which exponent? This guy?
Yeah, negative 1.
Okay. So you put it, okay, so you do that first, that's the parentheses. So I'm just gonna write it over here. But so it's 3, -1, x, -1.
And then
And then
you to the bottom.
and you put them at the bottom, okay. So since they're negative, you put them at the bottom. So let's take a look at this. So 1, 3, 1. I'm just gonna keep it like this for now. 3 squared. And then you have this x here, right?
Yeah.
All right. So what do you do with this one right here?
2
There's a
plus
1.
1.
Okay. So you add them, right?
Yeah.
So 1 plus 2 times this by x. I'm just gonna take out the multiplication signs. And then you simplify. 3 cubed, 2 plus 1. So that's 1 over 27x, right?
Yeah.
And that's it. Like, that's not that bad, right? Like, you look at this, you look at like what you have in the beginning, and you just apply each step, or what you had here. You just apply each individual like exponent rule. And always remember PEMDAS.
Yeah.
And that's it. You just apply all these rules. And then let me see if there's another one. Oh, there is another one. Okay, let's take a look at these ones. So this one I don't think we've seen it that much yet, but you'll see it like, you know, like maybe, but the same rules apply. Like all the other 7 rules, it applies here too. So fractional exponents. Fractional exponents. That's really what it is. It's just an exponent that's a fraction. So like if you had this, right, 2 to the 1/2. What did this equal again? 2 to the 1/2. What does this equal? If you remember.
1.
Like if you have a 1/2 exponent, what is that? You remember this guy?
Oh, yeah. The
So
square.
yeah, so 1/2, just the 1/2 itself. There's actually a you know, like a 2 that's hidden right here, because it's 1/2. It's a square root. It's a square root. So this is equivalent. But what if you had like 2 and 1/3? What is that? 2 to the 1/3. It's kind of similar. It's similar to this. So what is that one?
The 3 is on the.
This guy?
Yeah.
And then you just put the same thing in here. So these guys are similar. This is the fractional exponent. This is what that means. And then like, let's see if you can evaluate, like, you know, using the fractional exponent and something else. Let's see if you can, because then now you're gonna have to bring in your, you know, operations with like mixed numbers. So 2 to the 1/2. Actually, let me write this in a different way. So let's go with like square root 2, right? And then you times this by let's see, like x. And then I'm gonna make this all like to the -1. This is a little bit complicated, but let's just go with it. To the -1. And then let's make this like 2 to the -2. Okay, what do you do first?
Put the -1 on the x and the 2.
Okay, put the -1 to the x and then the 2. What is this 2 though, first of all? What is this 2, square root 2?
2x.
So the square root 2 to the 1/2, right?
Yeah.
So you might want, every time you see something like this, you might want to write the square root in terms of like it's a fractional exponent. So you do 2, right? 2 to the 1/2 first, right?
Yeah.
And then you times it by -1, right?
Yeah.
Okay, now that's the top one. Now let's look at the bottom. So 2 to the -2. I'm just writing it and doing it one by one. And then so let's times this guy now. So -1, 2x to the -1, 2 to the -1/2. And then 2 to the -2. There's a lot of negatives here, and there's a fractional exponent. What do you do with these negatives?
Put them on the bottom.
So switch them, right?
Yeah.
Okay, so let's switch the bottom one first. 1 let's keep this guy. X to the negative one, wait. X to the 1, 2 to the 1/2. And then this guy, let's move it to this one. So 2 squared. X, I'm gonna leave this guy because it's just 1. And then let's say like 2 to the 1/2, right? That's what you have, right? 2 squared over 2 to the 1/2 times X.
Yeah.
So what do you do now? These are the same base.
Subtract.
Which one do I subtract?
2 and a half.
Okay, so that's good. 2 minus 1/2, so that's a mixed number. And then you're gonna have X down here, right?
Yeah.
So now you have to do this thing, right? So what is that? Like, so that's gonna be 4/2. I mean, like, obviously, yeah, it's like 4/2, right? Minus 1/2, right?
Yeah.
And then like it's just bring in all the things that we've learned. So that's 3/2, and then X, and this one right here, you can actually you can actually simplify this. So let's see if we can simplify this. So like I'm gonna show you how you do it first. So
Couldn't it be 3 and 1/2?
3 and 1/2.
Yeah, 3 as the base number, and then 1/2 as the exponent.
1/2 as the exponent.
Yeah.
But what about the 3? So you mean like this, like this, like this? So like, let me see first. So like, for this one, like it's a little like, remember if you have like 1/2, so it's like 3, right? And then you have a 1/2 too, right?
Yeah.
It's kind of like that, yeah. Like, so this 3 goes with the 2, right?
Yeah.
And then the 1/2 is what? What is 1/2?
Divided by 1/2.
Like, what is it? It's a square root, right?
Oh, yeah.
So it's square root, and then you over X. So what is this one? The square root of 2 cubed. So you have 2 squared here, right?
Yeah.
And then you have another 2, right?
Yeah.
This is what you usually do. So like when you have a 2 cube here and then you have a square root, you split them like this so that you can do something with it. So 2, you could just do you could pretty much like reverse the rule, right? Which rule was that? That's the product rule. It's like reverse of the product rule. So you got 2 cubed and then you make it 2 squared times 2 to the 1, right? That's like reversing it. Does that one make sense? Like why we're doing this one? I'll show you why though. It's like this guy right here, you can split it to this guy, right?
Yeah.
And then I'll show you why you do that now. So the reason why you're splitting it and you have this you're timesing like this is because the square right here, it applies to both of them now, right? So it applies to this guy and it applies to this guy, right?
Yeah.
So what is the square root of 2 squared times the square root of 2? What is the square root of 2 squared? What's the square root of 2 squared?
2.
Yeah. Yep. Exactly. And then so when you do that, it just cancels out. You have 2 here, and then you have root 2, right? You have the square root 2 still, right? This guy.
Yeah.
And then it's X. So that's how you do that one. This is the same as 2 to the 3/2 over X. They're pretty much the same. Does that one make sense?
Yeah.
Yeah, it's not that bad, but like it's just how you like the meaning of a radical, the square root, what does it mean? Because like sometimes when you're looking at this, you can't see this one, right? Until you split them, like what we did here.
Yeah.
But that's just a skill that like over time I think we're gonna cover radicals in like right now. Let's take a look at, that's exponents. Okay, let's try doing these guys now. So let's do 29. What do you do first?
Add up all the exponents.
Okay, so you do 4, right? And then what do you do with the m? What is m? Or tell me what to put on the top.
4 plus 3 plus 3.
These are m, right?
Yeah.
For the m only first.
Oh, 4.
4 plus 2. Can you see the letters?
Yeah.
Okay. So the m, what do you do with it? Is it 4 plus?
3.
But then the m is over here though. Isn't it 2?
Oh, 2. Yeah.
Yeah. So 4 plus 2. Okay. 4 plus 2. And then what about the n?
3 plus 2.
Okay. What about the p? Is the p top or bottom?
Both.
Yeah, but then like the final one, where do I put the p?
On the bottom.
Okay. And then what do I put for the exponent? 4 plus
3.
Gee, hold on. It's not plus. What am I doing? This is not plus. It's a quotient rule, right? This is a quotient rule. 4 minus 3, right?
Yeah.
So a quotient rule is minus. It's not plus. It's when you're doing like when you're doing the product rule. When you're doing the product rule, this is when you plus it. But when you do like 4 divided by m2, right? This is you subtract it, right? 4 minus 2, right?
Yeah.
Yeah. So 4 minus 2, 3 minus 2, 4 minus 3. So let's simplify those. M second, n by itself 1, 3, p by itself 1. So that's the answer. Okay. Let's try this one right here. What do you do first?
3 minus 4.
So this is a little
3.
confusing. The first thing I usually do is like get rid of these negatives so that it's not confusing. And then these zeros. What do these zeros mean?
1.
Okay, so they're pretty much gone, right? They're goner.
Yeah.
Let's pretty much so let's rewrite these guys. So that's like y minus 1, z minus 1, x minus 4. Okay, let's get rid of these guys next, right?
Yeah.
And what do you do? What do you do when you have negative exponents? Okay, so you switch these guys. So 3x cubed, and then I guess x 4, y 1, no, so and z 1, right?
Yeah.
So what do I do with these guys?
Subtract them.
They're being multiplied.
Oh, add them.
Yeah. So when they're being multiplied, you add them. When they're being divided, you subtract them. So x 3 plus 4, and then y z. So 3 plus 4 is 7 yz, and that's the one. 3x to the 7 yz. Okay, I know with the one with the negative exponents, they we'll do more practice of those. Like I'll get more practice some of these guys. Maybe. Why don't we just do one right here? Let's do this guy. Yeah, the negative exponents really messes with you. What do you do first?
Switch the negatives.
Okay, good. So you switch the negatives. So let me rewrite this. So x to the 4th, x squared. You put y cubed up top, right? And then
Yeah.
y to the 4th. Try not to do like multiple mental math with these ones. Don't do mental math until later. All right, every step. So okay, look. So you do z. I think there's no z up top now. Z 4 and then z to the 3rd, right?
Yeah.
Okay, what do you want to do first?
It would be 4 minus 2 for x.
Okay, 2/3 of x, 4 minus 2. What's next?
On the bottom, it's 4 minus 3
For which variable?
for y.
So 4 minus 3. What's next?
Z plus z 4 plus 3.
Yeah, awesome. This is good. Okay, and then you just simplify, right?
Yeah.
So x squared, this is the easy part. 3y z to the 7, z to the 7. Okay, I think you got this one. We'll do more once the negative exponents and like switching them and then like adding quotient ones are usually the more difficult ones. All right, let's do these ones with like positive exponents. So what do you do here?
Can you zoom in?
Yeah, it's a little blurry. Okay. What's the first thing you do?
Add the 4 to all of them.
Okay. So you do that. So x. I think we'll just stick to this one for now. Let's just make it big. I think we need more price. So x -2 times 4, and then x -3 times 4. Okay, and then what do you do?
-2 times 4 and -3 times 4.
Okay, so -8, right? And x -12. So what's next?
Multiply both of them.
Like how? What am I supposed to do with the exponents?
It would
They're
be,
they're negative, right? They're negative, right?
yeah,
So what's the rule with a negative?
put them on the bottom.
Okay, I usually do it that way first, so that there's no confusion with like I don't like working with like negatives. So x 12. So now what do you do?
Add them.
Add the what?
8 and 12.
Yeah, so that's 1 x 8 plus 12, right?
Yeah.
So 1 x to the 20th, right?
Yeah.
Okay, so that one's not that bad. Well, like yeah, these are good practice. So let's do this one now. So what do you do first?
Add multiply the -3 onto the 4.
Okay, so x 4 times -3, right?
Yeah.
And then the next thing is you times this by 2. Oh, you just keep this guy first for now. I'm just gonna make it so no one's confused. I'm just gonna make this like parentheses. So, and then yeah, because like there's like x's and then like it's gonna make it a dot. It's just the same thing. So that's gonna be -12.
And then put it on the bottom.
Okay, so you put this guy at the bottom, and then this guy's up top still. Okay, what do you do next? What do you do next? These are x's.
So minus them. Minus
From
the and the 4. Because
okay,
both of x.
yes, that's good. So there's no more x's up top, right?
Yeah.
So there's gonna be x 12 minus 4. So 2x, that's gonna be 8. 2 to the x, 2 over x to the 8. So that's the answer. They're not really bad, but like looking at like this, like you'll never imagine that you got to this guy. But really, that's just all part of algebra. Algebra is just messing with it's not an equation yet. We call this an expression. like evaluating the expression, like simplifying. It's simplifying the expression, and once you put in like an x equals something, that's what you call like evaluating. And then you make this equal something, it's an equation. Okay, let's do this one. What do you do first?
Multiply the 3 onto the n.
Okay, and 3 times 3, and then times 2 to the n to the negative 1, to n to the 9th. What do you do next after this one?
Put the 2n on the bottom.
The 2n, or just, is it both of them?
With the exponent.
Is it the 2 as well, or just the n?
With the 2n with the negative 1.
Yeah, but then do you put both of them at the bottom?
Yeah.
The 2 doesn't have a negative 1, right?
Yeah.
So like this one stays on top. It's only this guy, right?
Okay.
Yeah, that one is like when you have something like that, because the exponent is like where if it was like this, like this guy, if it was this one, then you put both of them at the bottom. But since you don't have the parentheses, it's so okay. So you put n, so n9, right? N9, and then I guess I'll put the 2 right here, and then you put this guy right here. Okay, so what do you do now? Both of these are n.
Yeah, take out the n.
What do I subtract?
The exponent.
Okay, but so what is the subtraction though? N what?
9 minus 1.
Okay. So then that's it. There's no more fraction. That's it. That's how you do that. Okay, that one wasn't that bad. Let's do something more difficult. Let's do this guy. Okay, it has a negative exponent at the bottom. That's good. What do you do first?
Two minus.
So for these ones, we didn't really, because we didn't have like things getting multiplied. Like you know how when you have things in the numerator and then denominator, it's kind of like having a parentheses. Like over here. What would you do first with like these? I guess one thing to do is this 3. The 3 is up top and bottom, right?
Yeah. Cross out the 3.
Yeah. Like when I see something like that, when there's a 3 and same number up top, I immediately just cross them out because I don't want to do the high level math like arithmetic. So that's good. It takes out like the arithmetic. So then maybe the next thing is multiply these guys, right? So you do this, and then that's when I finally work. When I finally have one number, there's only one number. That's when I finally work with the exponents. Let me just rewrite this first. X squared y to the 4th, x, and then x minus 3 y squared. All right, what do I do first? And then when you have something like this, it's like there's a parentheses up here. So what do you do first?
For the 8x with the 2, do 2 minus 3. 2 minus.
Let's see if that works first. So you wanna do these guys?
Yeah.
Okay, so you wanna move this up top?
Yeah.
Okay. Yeah, let's see if that gives us the same. I think it should. It's just algebra. So x squared, right? And x cubed y to the 4th. I guess I'm just gonna make this all, x squared y to the 4th. They're all pretty much getting multiplied in x. And then this is y squared. What do you do now?
Um, 2 plus 3 for the x's.
Okay.
plus 2.
So this guy, this guy, and this guy. Okay. And
then
there's one more. There's
two.
one more, right? What about this guy?
Oh, plus 1.
Plus 1. Okay, good. Good, good. Okay. And then what do you do next?
Multiply all the x's.
Okay. Yeah. You mean these guys?
Yeah.
Okay. Let me just rewrite this first. So y squared. Okay, so that's 8x. 2 plus 3 is 5. Plus 2 is 7. Plus 1 is 8. Okay. And then so I have this guy now, right?
Yeah. And then 4 plus 2 plus 4.
4 plus 2. 4 plus 2.
Plus 4.
But okay, but this is at the bottom though, right?
Yeah.
So do you plus it?
Oh, 4 minus 2 plus 4.
4, okay, minus 2 plus 4. Okay, that's good. So now it's 8x8 to the 8th, y, 4 minus 2, that's 2 plus 4, that's 6, 8 minus 2 is 6. Okay, and then that's all of that pretty much reduces to this guy. All of this guy right here, which was like super complicated to look at. So that's really nice, right?
Yeah.
So that's why, yeah, algebra is really neat, because like something in the beginning could look so ugly, and then after all this algebra, then you can like just obviously you don't want to be solving like if you make this equal like a number, right? You make this equal like a number, right?
Yeah.
You don't want to be solving for like so many different x's, like x equals this. You only want to simplify it first, which you'll see later on. You have to simplify this first. Simplify. And after you get like some number, whatever, just whatever that number we just wrote, 6, and then you make it this guy, right? And then the second thing is simplify first. The second thing is solve. Solve for x and y. But in this case, you only have one equation. So we'll talk about that later on when you have like two variables that you have to solve for. You're gonna need another equation. Okay, let's take a look at this guy. What do you do first with the numbers?
2 add put the 2x with the exponent on the top.
Okay, you could do that first. So put this guy.
Yeah.
Okay, so I'll put 3x squared, y squared, and then x to the 1, if it helps. And then the 2 stays at the bottom, right?
Yeah.
2 times 4. And I like putting the x's first. So what do you do next?
Two plus 1 for the x's.
On the top?
Yeah.
Okay, 3x 2 plus 1 y squared. And then 2 times 4x squared y. Okay, so it's 3x 2 plus 1 is 3y squared. 2 times 4x squared y. What do you do next?
2 minus 1 for y.
Okay, 3x cubed y 2 minus 1. So there's no more y at the bottom, right?
Yeah.
2 times 4x squared. Okay, what do you do? Let me, obviously I didn't do that arithmetic. So 2 minus 1 is y, and then 2 times 4x squared. What do you do now?
And then 3 minus 2.
So 3x 3 minus 2 y. So the x disappears at the bottom, right?
Yeah.
You only have the numbers now. So it's 3x, 3 minus 2 is x, just 1, and y. And then you just do arithmetic, right?
Yeah.
And so 3xy, and that's 8, 3/8 xy. Good. So yeah, that one isn't that bad. As long as you know, just remembering the rules. As long as you remember the rules, and then like really, and that's all it is really. It's the same as like PEMDAS. You remember the rules, then you, if anyone were to ask you to do something like these operations, then you can just do them on the fly. It's just remembering the rules. And let's do something harder. Let's see. Okay, let's try doing this one right here, 15. What do you do first?
Multiply the 3 and the 4.
Multiply the 3 and the exponent?
Yeah.
Okay. Do I distribute them?
Yeah.
Okay. Okay, so b(a) to the 4 times 2 to the negative 3, right?
Yeah.
b to the negative 3, a to the 4. What do I do with the 4 and the 3? 4 and negative 3, what do I do with them? Do I times them?
Yeah, multiply them.
Okay. So stick with the dot. So 4 times negative 3. So let's do some arithmetic. I'll just skip that for now. B negative 3, A negative 12. What's the next step?
Put the negative 3s on the bottom and the negative 12.
Awesome, yeah, that's good. So B A to the 4, 2 cube B cube A to the 12. Okay, what's next?
Four minus 12 minus 4.
For the what? The A, right?
A.
Okay, so A disappears from the top, right?
Yeah.
So B cube A 12 minus 4. Okay, let me do the arithmetic. B 2 cube B cube A, that's 8. What's next?
3 minus 1 for the B.
Yep, and so there's nothing on the top now, right?
Yeah.
So 3. Yeah, don't forget to put these ones when there's nothing there. So 2 cube B 3 minus 1 A to the 8. So doing the arithmetic, 1 over 2 cube B 3 minus 1 is 2 squared A to the 8th. And then what's next?
Add all the exponents.
You can just do them, right? Just do them. Okay. So 2 cube, that's gonna be 8. And I usually like arranging this from like in descending order. The A's I like to put it first, and then the B's second. And that's the answer, right?
Yeah.
Yeah. All right, let's try more of these. So let's see. So you guys haven't touched on exponents yet?
Oh, we did last year,
Oh, you guys did it last year?
but not with fractions.
But what about like with variables?
Maybe.
Do you guys do something like this?
No, it was way easier than that.
Okay, so the one you did that you guys did is easier, so this is a little bit harder.
Yeah.
Okay. Yeah, I was wondering, like, if you that's the thing, like if you learn it like one point and then like you don't see it again, you tend to forget it. But like now, since you guys are using like introducing you to guys to solving equations, did you guys solve equations before yet?
Yeah.
Like what kind of equations though? The just 1x?
Two-step equations. We solved two-step equations.
Oh, maybe we should touch on those. What about inequalities?
I don't remember doing inequalities.
Okay. So two-step equation, yeah, we'll touch on that like maybe. Okay, I think we're done with these because I really wanted to touch on the equations. Let's look at like we can actually skip that and then go to here you go these ones because I want to see how like these ones we should practice because they're gonna get harder once we graph them and doing the inequalities. Two-step equations. So let's see. I mean, this can go multiple steps. It doesn't have to be two. There's like multi-steps. Let's take a look at this one. Let's then all these ones you have to solve for the variable, whatever the variable is. What do you do first?
-2 on both sides.
Okay. See, this is the bread and butter for like algebra. Like the reason why you do simplifying expressions is so that you can solve them, solve the equation. So you do this right? 4. And then this is 0 on that one side, and then you do this one. So what do you do now?
And then times 4 on both sides.
Times 4. Awesome. I like doing this one actually. So then this one cancels on the other side. So that's 4 times 4, right? It's 16. And then I guess that's it, right?
Yeah.
1, 2, two-step. All right. I mean, that wasn't. We could make that harder. Let's go. Let's do something harder. Let's do this guy right here. What do you do first?
Times 6 on both sides.
Okay, times 6 on both sides. Good. Yeah. See, yeah, you have done this. That's good. So -6, right? And then there's nothing on the other side, on the right-hand side. Okay. What's next?
And then -5 on both sides.
-5, -5, -11, and you're done, right?
Yeah.
Yeah. 1, 2. And that's it. Okay. Let's do. Where's the one with exponents? There's supposed to be one with exponents. Exponents and then like radicals. Okay, I guess this isn't that bad. Let's do this one. Like you already know square roots, right? Like we talked. It's like a pretty much the exponent, the 1/2, right?
Yeah.
And then now let's try to apply that to like something of a way of solving an equation. So let's look at this one. What do you do? So this one is squared, right? Or like what is the inverse of squaring?
Half.
So x is 1/2 here equals 10. So how do I get rid of this 1/2?
Divided by 1/2.
Which is like same as what? Timesing by what?
2.
Yep. So that's squaring, right?
Yeah.
So I square both sides. So when I square both sides, I pass it to the exponent, and I make this an exponent. So x, I'm just going to write down the step. X times 2, 10 squared, right?
Yeah.
And then so this guy is what? Just x now, right?
Yeah.
And then this is 100. Yeah, so that one is it. What do you think of that one? This one is just applying that, the fractional exponent thing. Okay, let's try this guy. What do you do first?
Times 2.
To what, like squared?
Yeah.
Okay, so let's square it. That's the first step. Okay, so 10 squared, right?
Yeah.
And then like when I square the radical, what happens? It disappears?
Yeah, it goes away.
Okay, so like that. And then so let me just do the arithmetic. M over 10. What's next? This one's easy.
And then 10 times 100.
Okay. So 1000 m. All right. So that it's just the radical one is the one that like just add that to your repertoire. You know that add it to your collection of rules, and then it's all the other steps that you've learned so far. They're all pretty much the same. PEMDAS. It's just solving the equation now. Let's do one that. Oh, this one is like is this 3-stepper? Okay, let's do this guy right here. What do you do first?
Plus 8.
Okay, plus 8. So 5a minus 5. That's really bad handwriting. 5a minus 5 equals 8 minus 3. That's 5.
And then square.
Awesome. This is nice. Okay. And then what happens to the radical?
It goes away.
Okay. So 5 squared, that's, what is that?
25.
Okay. 25. And then what's next?
Plus 5.
Okay, so these are nice. 5a. And then, so what is that? 30, right?
30. Yeah.
And then what's next?
Divided by 5.
That's like a 3-step right here. So that's 6. How was that one?
Pretty easy.
Okay, let's do something difficult. So these ones you're probably done, right? You've done these ones.
We haven't done it with the squared.
You haven't done it with the squared. Okay, that's good to know. But then like knowing the exponent rule now, you could extend it to what you know already, right?
Yeah.
Yeah, that is what math is. Like math is just, you probably played with Lego before, right?
Yeah.
Math is just Lego. Like you have these different like blocks, and then once you put them together, you create like a dinosaur or something, So that's just what it is. You create something, and then they're just different building blocks. Okay, let's do actually this one. Let's do this one right here. What do you do first?
Could you square the one that it's equal to?
You mean like this guy?
Yeah.
Yeah. Like when I look at this, like you know how when you have the same thing on both sides, right? Left hand and right hand side.
Yeah.
You have both of them happening at the same time. You can just like take them out in essence, or squaring it, right?
Yeah.
So when you square it, you just essentially just take out the radical. So it's like this. So what's next?
Minus 72. Or you can times x.
Times x?
Yeah.
For this one, like I think the easiest one is don't try to work with this fraction. Like I usually get rid of the fraction first. So I would do this right here. Right?
Yeah.
So the fraction is gone, and then I just have to do some arithmetic. So 72 times 5. So that's going to be like this guy pretty much. 72 minus x, right?
Yeah.
And then you distribute this 5, right?
Mm-hmm.
360 minus 5x. That one's easier, and this one's easier, right? Like if you did the 72 on the other side, you have to work with a fraction. So what do you do now?
Divided by x.
Like you have this minus 5x here, right?
Yeah.
And then you have this other x right here. You could do the same thing, right? You can plus what on both sides?
5.
5 what?
X.
Yeah. So you could, because they're like terms, you can add them, minus them. You just have to do the opposite. So 360. And that's 6x, right?
Yeah.
And then what's next?
Divided by 6.
Okay, so that's 60. Okay, so that's good. Yeah, let's do another one like that. That one, like, if you have the radical, like I said, you just do the opposite, which is like square root. Opposite is just squaring it. Let's see. Let's see if there's another radical, like an exponent. Okay. So this one, is there a radical here? Oh no, it's just more exponents. Oh no, we actually didn't do this one because there's exponents now. And fractions. Let's do this one. What do you do first? What do you do first with this one?
Add the exponents.
I would probably, for this one, like, you know how this is the same as this guy, the denominator?
Yeah.
So what happens when you have the same denominator? You could just add them, right?
Yeah.
But then you keep the bottom, right?
Yeah.
So you have what? M minus 4. Then plus 2. And then I would probably just do the arithmetic first. So 3m squared. M minus 4 plus 2 is minus 2. Minus 4 plus, yeah, minus 2. And then the 3m squared. So what do you do with this now? How do you solve for m?
Plus 2.
Plus, like, if you have a fraction right here, you can't just like add this on, because you have to add like the whole like the whole entire like you just don't do it that way. If you have a fraction, do you remember doing it like when you cross multiply?
Yeah.
So you cross multiply them.
Okay.
So okay, let's do that. 3 times 3m squared equals m squared m minus 2. Okay, and then so you just do arithmetic. Oh, it's not really arithmetic, but you just pass this on, right?
Yeah.
So you do that right here. Another thing actually that you could do is we'll talk about it later. It's like you could actually take out this m, because there's both m squared on both sides, right?
Yeah.
But like, let's not do that. Like, let's just do, go along with what we're gonna do right now. So 3 times 3, that's 9 m squared equals m. Actually, hold up. Let me think. M cubed minus, no, actually we do have to do that one, because then it's gonna become you're distributing this guy. Okay, let's go back. So you know how you have m squared here and m squared here being multiplied?
Yeah.
You can just get rid of that, right? And how do you get rid of that? You divide it by m squared, both sides, right?
Yeah.
Yeah, that one, like this one, something like this, that's what you have to do. It's the same thing as what you do if there were numbers. So since you divided this by this guy and you divide this by, so that disappears. So now you have 3 being times by 3 equals m. The m squared is gone, m minus 2 now. And then you just do this. And what do you do now? There's no more fractions.
Plus 2.
Yeah. So every time you have a fraction, you can't just like, you have to cross multiply them. But then the way to get rid of the fraction, the way you get rid of fraction is to cross multiply it, and then get rid of the fraction before you do any arithmetic. So 11 m. So that's how you do that one. Okay, let's try another one like this. This one's a little bit like, you need to apply everything in this guy. Let's do this guy. What do you do first?
Um, 5n minus 5n.
Let me see, 1 over n. So this is the same denominator, right?
Yeah.
So are they, you write it like this, and then what do you do at the top?
N minus 1 minus n minus 1.
And this is a tricky thing. You know how you have this negative right here?
Yeah.
We'll do more of these. Like these get really complicated. These are like the small rules. So you know how like this is negative, this top part right here?
Yeah.
So this is a negative 1 times n minus 1, right?
Yeah.
Does that make sense?
Kind of.
Okay, because this negative right here is being times to this whole fraction, right?
Yeah.
You can't just say, you can't just ignore, if this was plus, then yeah, it's n minus 1. It doesn't matter. The moment that it's negative, the moment that like this thing is negative, this is when it gets like, the small rule is you put a negative 1 right here, and you times it by whatever is in the numerator. So what do you do now?
One times.
You distribute this guy?
Yeah.
Okay. So 1 minus n minus 1 times minus 1 is plus 1. 5n. See, this one actually looks different. That's because of the negative. So what do you do now?
One minus 1.
You do the arithmetic here, right?
Yeah.
Okay, so 1 plus 1 minus n over 5n. All right, now we have fractions. That's just fractions now. Everything's simplified. What do I do next?
Put
Same
the
with
n on the bottom.
the what one?
Put the n on the bottom.
Put which n?
The one on the top. The one that's a negative.
It's a negative exponent though, right? It's a positive. Oh, you only do that with exponents, right? So if you have something like this, you do what? You cross multiply. You cross multiply them.
Yeah.
Yeah, it's like we'll do more of these. Like these are the steps of like simplifying it. That's like, and then so 5n, right? And then n 2 minus n. What can I do with the n? This n,
Distribute them. Cross them out.
because I'm there on both sides, right?
Yeah.
Yeah. Same thing. Like you could technically just times this by 1 over n. That's the same thing as crossing them out. But crossing them out is not really mathematical. Timesing them by the same number, 1 over n, that's the mathematical way. But crossing them out is the result. So 5, and then so 2 minus n, right?
Yeah.
What do you do next?
Minus 2 on both sides.
Yeah. So
And
this one now makes sense, right? It's this part, the from here to here. From here to here is like it's okay. What's next?
divided by negative.
Oh yeah, shit. It's a negative 1. Okay. And then so n equals,
Negative 3.
yeah. There you go. What do you think of these two? Like when you do this?
They're kind of like confusing when they're not simplified yet, but then once they get simplified, they're easy.
Yeah. Yep. I think we need to do like more of these ones. It's just what when you see some fractions, every time you see a fraction, it always messes with you. And there's like, we haven't really seen anything yet where you remember in like when you have like different denominator fractions, right?
Yeah.
That one, it gets even more difficult. Like this one right here, and then this guy right here. Okay, I think maybe I'll do you have this do you have this worksheet, right?
I think so. Yeah.
Okay, I'll actually, well, let's do one of these, and then I'll like you know, if you can do at least like some of these, like practice doing this guy, and then you know some of these other guys. I'll show you like how you do this one now, and then you know, obviously like the ones where the denominator is not the same. No, this one is the same denominator, or actually no, not this, but the exponent, like these ones, they don't have the same denominator. Maybe we can practice this and then do this again. What do you think of that? Let's do this again like next time.
Yeah.
Okay, let's try do this one last, and then let's see. So if these don't have the same denominator, what do we do again?
Cross multiply.
You have to find a common thing, right? The LCM, I think. Yeah. Like you have to find something that's common to these guys, and then multiply them in both sides, right? Like both fractions. So this one, what I usually do is I'm just gonna rewrite this left hand side. What I usually do is this is what I do. Whatever is in here, that's not in here, I just multiply it. So x squared is already in both of them, right?
Yeah.
But it doesn't have a 6. So I do this 2x squared and then times 6. And then whatever you did to the bottom, you're gonna do to the top, right? Right?
Yeah.
So you do x plus 3 times 6. This is when it gets complicated. You times it by 6. So this guy has an x squared, but it doesn't have a 2, right?
Yeah.
So this is what you do. So you do 6x squared times it by 2. Now they're the same, right? Now they're the same.
Yeah.
So whatever you do to the bottom, you do to the top. So 1 times 2. Now you have to simplify that. So let's try. Then what I usually do is I write, now that they have the same bottom, I write them as one fraction. So this is what I do. 2x, or I guess I can just do the arithmetic. Sometimes I don't do the arithmetic because something simplifies, but I'll just do the arithmetic. The 6 and the 2, that's 12. And then you have the x squared. And then you look at both of their numerators. So you have this 6, right?
Yeah.
And then you distribute these. So 6x plus 18. And then you have this minus 1 right here, right?
Yeah.
So what is this minus 1 to these guys?
1 minus 1.
So this one's an easy one. So it's just minus 1 times 2, which is negative 2, right?
Yeah.
Okay, so that's what you have now. You always want to, that's the step. The step is when you have different denominator, like with variables, you just times, you times in both denominators, both fractions, the thing that's missing. And then whatever you do to the bottom, you do to the top. And then you make them one fraction, and then you simplify the top. That's really the step. So now this looks like something we've already seen, right?
Yeah.
So then I'll just do this really fast. It's running out of time. So 18 minus 2, 6x, 18 minus 2, that's 16, right?
Yeah.
12x squared. And then what do you do with this one?
Cross multiply.
Okay, good. So you cross multiply. 12x squared plus times 1 is 12x squared. And then 3x squared times 6x minus 16. What do I do with the x squared? What do I do with the x squared?
Cross them out.
Okay, you cross them out. So 12 equals 3. 12 equals 3. 6x minus 16. So there's actually an easier way of doing this. What do I do with the 3?
Distribute.
I could distribute, yeah, right? But like you could also divide, right?
Oh, yeah.
If you divide by 3, it's easier in math. So you divide by 3. 12 divided by 3, that's 4, right?
Yeah.
And then you're left with 6x minus 16. What do you do now?
Plus 16.
Yeah, plus 16. Now this is the one that we're used to, right?
Yeah.
And then you divide by?
6.
Yeah. And then you simplify the fraction. So 20 over 6. That you divide this by 2, divide this by 2. That's 10 over 3, right?
Yeah.
So that's it. Yeah. So yeah, please do more of these ones. These ones, does that make sense though? The one where you have to make the two fractions into one?
Yeah.
Okay, we'll do more of them. We'll do more of that next time. Okay. I think, sorry for like starting late today, but we'll do this again next week.
Okay.
All right, Milo. So yeah, let me know. Actually, we'll meet again same time next week. I'll send you the link to your dad or mom.
Okay.
Cool. Have a good one. Have a good week.
Bye.
All right. See ya.